The last of the review sections that we're going to do for our Calc 1 course is about trigonometry. I need to make sure you remember your trigonometric functions. A lot of students come into a calculus course having taken trigonometry a long time ago or just taken a pre-calculus, which is essentially just a brief review of trigonometry. Well, we are going to be using trigonometric functions in our calculus course, and I do need to make sure that you at least have the basics of trigonometry, that you're not afraid of solving trigonometric equations, you know what the functions look like, and you can evaluate the functions at any point. The good news here is when you took a trigonometry course, most likely you weren't allowed a calculator on some of those exams. For instance, if they said find the cosine of 30 degrees, most teachers would not allow you to use a calculator. However, in a calculus course, almost all teachers will allow you to use calculator during those exams, whether it be a non-graphing calculator or graphing calculator. Almost all teachers allow it. So the beauty of that is you no longer have to directly memorize your trigonometric functions at certain values. However, that does not mean you get away with not understanding them and that you shouldn't know at least the unit circle. So that's why I created this trigonometry review, is just to kind of remind you what are we talking about with trigonometry. Is where a lot of students don't feel comfortable. Let me just give you the basics of what you need to be able to be successful in our 220 calculus course. So the first thing I want to remind you of is what's an angle. So an angle has three parts. It has an initial ray, and then it has what's called its terminal ray, and then the center point is called the vertex. And so what we always do is we put it in standard form, where the initial ray is always on the positive x-axis and the vertex is always on the origin of the graph. And if you notice, they always open up in a counterclockwise direction. By the way, if you remember, I don't know if you know this, in the coordinate plane, if you look at how do they number the different coordinates, they do 1, 2, 3, and 4. If you talk about which coordinate are you in, which quarter are you in, why did they do that? They did this because of trigonometry. If you think about an angle with its initial ray on the x-axis opening up, it opens up in a clockwise direction, so that 1, 2, 3, 4 comes from an angle getting bigger and bigger and bigger. I always wondered why they didn't start on the top left and do it just like we read a book, right? Top left, bottom right. So they did it because of angles, just to let you know. So that's where rays come from, that's where angles come from. An angle is the measure between those two rays. We usually use theta is our letter that we usually use to represent an angle. Okay, it says, is it assumed that you are familiar with the degree of an angle? It is common practice to use theta, which is the lower Greek letter theta, to represent both the angle and its measure. Angles between 0 and 90 degrees are called acute, and between 90 and 180 degrees are called obtuse. Okay, let's look at this next one. It says positive angles are measured clockwise. Positive angles are measured, counterclockwise. So a positive measure goes in this direction. That would be a positive measure. And a negative angle is measured clockwise. This would be a negative angle right there. Okay, so counterclockwise is positive, clockwise is negative. Says for instance, the figure below shows an angle whose measure is negative 45 degrees. You cannot assign a measure to an angle by simply knowing where its initial and terminal rays are located. To measure an angle, you must also know how the terminal ray was revolved. For example, the figure below shows that the angle negative 45 degrees has the same terminal ray as the angle measuring 350 degrees. So what I'm talking about here is the picture. I drew the red angle, that's the positive, that's 315, versus the blue angle, which is negative 45 degrees. So if we have that same initial ray and that same terminal ray, that's not enough to tell you what the angle of measure is. You actually have to draw that red line or that blue line that I drew indicating the direction of the angle. But since they have the same initial and same terminal rays, those are called coterminal angles. Okay? So it says, in general, if theta is any angle, theta plus n of 360, or n times 360, where n is a non-zero integer, is coterminal. So if you remember, 360 degrees is a full circle. So it says, look, we can add or subtract any multiple of 360 degrees, and we're going to end in the exact same place. Why does that help us? Well, imagine if I wanted you to find the cosine of 400 degrees. 400 degrees is more than one revolution of the circle. So what I could do is 400 degrees minus the 360 degrees, which is a full circle. 400 minus 360 would be 40 degrees. So instead of finding the cosine of 400 degrees, I could find the cosine of 40 degrees. Okay, so that's really what that's getting at. Just remember, coterminal are angles that end in the same place.